What is inertial mass? Inertial mass refers to the property of matter that quantifies its resistance to changes in motion. It is a measure of how difficult it is to change the velocity of an object when a force is applied to it. Inertial mass is typically represented by the symbol m and is measured in kilograms in the International System of Units. According to Newton's second law of motion, the force acting on an object is equal to the product of its mass and acceleration, that is, F equals to ma. In this equation, m represents the inertial mass of the object. This law implies the greater the mass of an object, the greater the force required to accelerate it at a given rate. Inertial mass is a fundamental concept in classical mechanics and plays a crucial role in understanding and predicting the behavior of objects in motion. It is distinct from gravitational mass, which is property of matter responsible for experiencing and generating gravitational forces. However, according to the equivalence principle in general relativity, inertial mass and gravitational mass are equivalent, meaning that they are proportional to each other and have the same value for all objects. Here we are going to look at Newton's simple pendulum experiment, how they are equivalent, and we have got the formula for time period. Here for this simple pendulum system, the mass of the ball is m, the distance or the length is capital L, and the angle is theta. Angular displacement is theta. We know the torque is force into perpendicular distance. This is the gravitational force. mg is the gravitational mass and mi is the inertial mass. So here force is mg into g into this perpendicular distance is this distance. This distance is L sin theta because this angle is also theta. Now here it is L sin theta. As theta is very small, so sin theta is theta. Therefore tau becomes mg g L theta. Again we know tau equal moment of inertia multiplied by angular acceleration. Moment of inertia is inertial mass multiplied by the distance square, and alpha is d2 theta dt2. Here alpha is d2 theta dt2. Now theta is acting in this direction, then tau is acting in opposite direction. Therefore we will have a negative sign here. Now if we compare them, then we will have mi L square d2 theta dt2 equal minus mg g L theta. Now if we cancel them, mi and mg, considering that mi equal mg, inertial mass equal gravitational mass. Then d2 theta dt2 is g by L minus theta. We know that the acceleration d2x dt2 is minus omega square x. If we compare these two equations, then we will have omega square as g by L, and omega is root over g by L. We know the time period is twice pi by omega. So if we put the value of omega here, then it is twice pi square root of L by g. Now if we consider that these two masses, inertial mass and gravitational mass, are not equal. So when mi not equal mg, then the time period becomes twice pi square root of mi by mg L by g. So here you look that there is a ratio of the inertial mass to gravitational mass. So for this experiment, the Eotvos ratio is less than 10 to the power minus 3. What is this eta? Eta is A2 minus A1 divided by A2 plus A1 by 2. This A1 and A2 are the acceleration of two objects. Now let's find this Eotvos ratio in terms of masses. Say there are two objects M1, M2. The inertial mass of M1 is mi1 and inertial mass of M2 is mi2. The gravitational mass of M1 is mg1 and gravitational mass of M2 is mg2. Now the inertial force for the object M1 is F1, which is equal mi1 A1. A1 is the acceleration for the object M1. Similarly, we'll have F2, which is mi2 A2. And gravitational mass for M1 is F1 mg1 g. Let's write it for inertial force Fi1 and for gravitational force Fg1 and here Fi2. So Fg2 is mg2 g. Now these two are equal. So from here we get A1 as mg1 by mi1 g, and from these two equations we'll get A2 as mg2 by mi2 g. Now let us put these values here, then we will get twice. A2 is mg2 by mi2 minus A1 is mg1 by mi1, cancelling the g term, mg2 by mi2 plus mg1 by mi1. So this is the Eotvos ratio in terms of masses. To find this ratio, lots of experiments are going on. It has been started since 5000 BC. Still it is going on. Scientists are trying to find, is there any violation that in some cases where that the inertial mass and gravitational mass are not equal. In Galileo's experiment, in Newton's experiment, in general relativity of Einstein, everywhere it has been assumed that the gravitational mass and inertial mass are equal. Not only assume, it is experimented also. And for all those experiments, the Eotvos ratio have been found.